So in the previous video, we were able to do something that was called as a sentimental analysis. We found polarity and subjectivity, we plotted it, and we did some analysis about each of these comedians. Now the next topic is topic modeling. Another popular text analysis technique is called topic modeling, along with the sentimental analysis. Now let us see the goal of topic modeling. The ultimate goal of topic modeling is to find a various topic that are present in your corpus. Corpus means a text. So from the text, if you want the main topic, let's say summary of the text, then we use something called as topic modeling. Each document in the corpus will be made of at least one topic, if not multiple topics. So we are going to extract the one topic from each of these documents. Now, in order to perform topic modeling, we have an algorithm which is known as LDA algorithm. And this is one of the many topic modeling technique. It was specifically designed for textual data. Now we can use this algorithm to implement topic modeling. Now, to use topic modeling technique, we need to provide two things. First is a document term matrix, and the second, the number of topics you would like the algorithm to pick up. Once the topic modeling technique is applied, our job as a human is to interpret the result and see if the mix of the word in each topic makes sense. If they don't make up sense, then you can try changing up the number of topics, the terms in a document term matrix, and the model parameter, or even try different model. So that is the optimization technique here. So let us see what we are going to do in order to implement a topic modeling. So this is the attempt first. We are going to take all the text. So for it, we need this library, which is Gensim library. So for that, you can open the Anaconda prompt. So search for Anaconda prompt and type conda install -c conda force Gensim. So this is the library that you need to install, Gensim library. You can also install it by opening the command prompt, and here you can install it using pip install Gensim. So it is up to you which way you want to install this Gensim module. This should be installed first. Then after, if I run this code, then you can see this is already installed and already imported. We don't have any error. That means it's successfully imported. And I have printed our data underscore stop. So this was the data that didn't have that stop word. And you can see that I can also get the head out of it. Then you can see at the label, we can see these comedian names, and at the column we have something that is a word. So word is each of these columns, and the index is comedian name. And this is what term document matrix looks like, or document term matrix in our case. It is document term matrix, or DTM. We call it as a DTM. Now, if you transpose it, then it will become term document matrix now. So initially it was document term matrix. Now if you transpose, it will become term document matrix. So this process is to convert from DTM to TDM. So now if you run this line of a code, then you will see initially we had the comedian name into the label and the word into the columns. Now this position will be changed. Now the word will become column, or word that was in the column will become row, and the comedian name will become column. See here. So comedian name has become the column and the word here has become the rows. So this is what term document matrix looks like. Now Next thing is we are going to put this TOM document matrix that we have just created into the new GenSim format. So this is the way. So first of all, we have the data frame. We convert it to the sparse matrix, which is this TOM document matrix, and then we convert it to GenSim corpus. So we need to have this GenSim corpus in order to implement topic modeling. So this is the code to have the GenSim corpus. So sparse to corpus. So this first line will convert TDM to sparse matrix, and after we have this sparse matrix, we can have the corpus, and this is GenSim corpus. So this line will take the TDM, which is this document, and it will print the sparse count. Let me also print sparse counts. Then here we will have corpus, which is GenSim corpus. If I run it, then you can see this is a sparse matrix, and here we can see this sparse matrix created. Now corpus has just printed us the information, so I can just remove this sparse matrix from printing. So after having the corpus, I need to make something called as TOM document matrix containing this dictionary of location and the terms. So I need to create this thing. See here, I have used this CV. So what this CV means is it is a count vectorizer. If you go up, I have used over here before doing the sentimental analysis. It should be somewhere here. Okay, this CV. I can also copy it. This is the same thing, and I can go down and paste it right there. Over here. So this is the same CV, which is a count vectorizer object, and from there I have created a vocabulary items. So what this statement does is it will create a dictionary, and it will create something called as a dictionary containing word and their count. For example, in the dictionary, initially it will have something like this. Let's say we have a count, like I have a word and its count. Let's say I have a word like love, and its count on the entire corpus is 20. That means the word love has appeared 20 times. And let's say I have a word hate that has appeared 2 times. Now after we execute this line of a code, what will happen is we iterate first of all into these items, and we basically transpose key and value pair. That means after we do this, what will happen is the dictionary will be again created, and in this dictionary, first of all we will have 20. The value will be at first, and then we will have the word, and then again we will have value and then word. This is because to incorporate with TOM document matrix, we do something like this. So if I go back here, you can see first we have the value and the key. Key is the word and value is the count of that word. Now if I run this code, then you will see the dictionary printed with the count and the word. So count and word. Now that we have returned this ID to word, so here ID to word means we have the items and we converted first as a value, as a count and the word. So in the entire corpus, the word ladies has appeared 3608 times. The word gentleman has appeared 2700 or 2702 times, and the welcome has appeared 7130 times, and so on. So this is what we made. Now that we have a corpus, and what is a corpus? Corpus is a GenSim corpus which contains TOM document matrix and ID to word, which is this thing we have just created. Now we can supply this as an argument to our LDA model. Now this LDA model is the model that will implement topic modeling. So from the models, so if you go up, we have imported it right here. From Gensim, we have imported the models. So from the models, I'm going to use the model named as LDA model. So LDA model will be used for topic modeling. It will take corpus. So what is a corpus? Corpus is this Gensim corpus that we have created here. So after Gensim corpus is created, we have ID to word. So this is the word, and then we have the number of topic that you want to print and the passes. So this line of a code is basically going to create us a topic with a two topic, and number of passes means the word that we want to have in those topics. Now let us run this code. Then it is going to take some time, and here we have the two topics. The first topic contains the word like cause and this word really good, and it is really like kind of funny because the word good and the word sit is within the same topic, and we have this word like sit and the effort is within the same one, and this is not good topic at all. So the model is not working properly. Let us work with the three topics. Let us run it for the three topics now. So I have changed only the norm topics to 3. Everything remains the same. So if you change to 3, then you will get 3 topics. So at the first topic, you can see some of these words. So topic here means the word that have the similar meaning. For example, I have the words like, let's say, similar word. For example, I have the combination of word like love, and I have the word like, let's say, charm, or maybe I have a word like beautiful, so beauty maybe, and I have the hate, I have the crime, I have the word like suicide. These are negative word. Now if I want to make the two topics, let's say first topic and the second topic, then in the first topic, if I have the word love, now the word that is close to this word love will be in the first topic. Is the charm near to the love? Yes. And let's say the topic 2 represents the hate. Now the word charm is near to love or hate. It is near to love. So it is kind of like closer, or closer in a meaning. So charm is closer in the meaning to love than the hate. Beauty is kind of appreciation, so it is also a love. Beauty is love. Now hate is obviously near to the hate. Now crime. So crime, does it have a meaning that is related to love? No. So crime is more related to hate. So crime will be on the topic 2. Suicide is also negative word, so it will be in the negative, that is negative word collection. So in this way we make this 2 topic, and this is done by topic modeling. Now you can see some of these words are not related at all, but it has given us within the same topic. Now let us go with the 4 topics. So num topics here is a 4. So if I run this now again, then I will find 4 topics, and each of those topics will have the word that are related to it. Although our model is not doing perfectly fine at this moment, our topics are not looking that great, and we can just modify these parameters. Maybe let us change some corpus text, maybe pre-processing and so on, but this model is not working perfectly at this time. We are going to make this model work better in the upcoming videos.